Senior Director of Standards and Safety. I'm going to touch base on some IIAR standards and some ammonia refrigeration management practices. What the IIAR has is developed a suite of standards. And these are for closed circuit ammonia refrigeration systems. And IIAR 1 is the definitions and terminology used in the IIAR standards. And then the next is a safe standard for closed circuit ammonia refrigeration systems, which is IIAR 2. We have IIAR 3 ammonia refrigeration valves, IIAR 4 installation, IIAR 5 startup, IIAR 6 inspection, testing, and maintenance, IIAR 7 developing operating procedures, IIAR 8 decommissioning, and IIAR 9 is the minimum system safety requirements for existing systems. And today what I'm going to do is I'm going to highlight a couple of them, which is IIAR 2 for safe design and IIAR 6 for inspection, testing, and maintenance. And I'll show some pictures to help as well. In regards to RAGAGAP, R-A-G-A-G-E-P, in the bottom right, you'll see in a box, RAGAGAP is recognized and generally accepted good engineering practices. And your system can be a refrigeration system of excellence if it follows RAGAGAP for the design, manufacturing, construction, fabrication, its operation, and inspection, testing, and maintenance. So if you have those items, and what are you using to make sure that it was installed, is operating, as inspected, tested, and maintained to keep it in a safe condition. And then by following the RAGAGAP, the ammonia refrigeration system can be safe and function under all necessary conditions without representing risk or any dangers. So IIAR 2 and 6, as mentioned, IIAR 2 is a standard for design, safe design, and IIAR 6 is a standard for inspection, testing, and maintenance. What IIAR 2 is about is it specifies minimum requirements for designing safe ammonia refrigeration systems. It's pretty straightforward. And what IIAR 2 has 4 parts. It starts with a general purpose, scope, and applicability, and then it jumps into design and installation considerations affecting construction. And this includes, of course, general requirements, but then I've highlighted a couple. I'm going to go a little bit more into depth later. Machinery rooms, and then refrigeration equipment located in areas other than machinery rooms. And then part 3 is equipment, and I've highlighted some items there of the equipment. And then, of course, it has a part 4 appendices, which has explanatory materials. So the highlighted items, I'll touch base a little bit further. I want to show some pictures here so you can see what is a machinery room. Here's machinery rooms with compressors. Some show a pressure vessel and a heat exchanger plate and frame and such. Here's some more with the compressors. The middle one's a thermal siphon vessel that's overhead for oil cooling. And then on the left is a low pressure receiver for circulating for ammonia. Also, there is refrigerated equipment installed in areas other than machine rooms, such as the docks here. And you see the evaporators hanging overhead on central in both these locations. And then, of course, there's ammonia detection and alarms, visual and audible alarms. So the visual, obviously, blinking, flashing lights, and the alarms which you can hear with a certain amount of decibel rating. And then the ventilation is important, that if you're going to ventilate, emergency ventilate the machine room, that it would direct directly upward at a certain rate. So it's very important the type of ventilation you use. And then you have a switch that you can use it as needed, turn it on, off, and such. Also, another item that's key is overpressure protection devices that are located on certain areas of your equipment to prevent any overpressure buildup to be able to have it relieved. One of the key items here we're finding is you do where it's written in red, no valve installed between a pressure vessel and a PRV. So if you have a pressure vessel and you have the PRV or PRVs, dual PRVs shown here, that you do not want a valve between them. If you find a valve, a shutoff valve that's in between them and it's already installed, what you want to do is go lock it out, chain it out, make sure it absolutely does not get closed. And then someday, hopefully you can get that valve removed, but absolutely make sure that valve does not get closed between a pressure vessel and a PRV. Also, there's oil draining where you have a valve, shut-off valve in series with a self-closing valve. Here's some examples. You see the first valve coming out from under the equipment on each, and then you see a spring-loaded yellow handle valve that will close itself. Those are key items to have in series for when you do your oil draining. And of course, emergency eye wash and showers are very important, that they're ready and usable whenever you would unfortunately need to use one, but they are ready, good condition and cleaned, and just, they can be portable as shown in the one on the bottom right, but also the ones such as wall mounted. You want to have them signs, you want to have people trained to know where they're at, and of course they're checked frequently. One item that is a prohibition on is having an open flame. So there's no open flame fuel burning appliances that should be in a machine room. That's just one item that you do want to avoid, because you never want to have a chance that if there was ammonia release that it could ignite the ammonia vapors. Now, IR 6, inspection, testing, and maintenance, that specifies minimum requirements for inspection, testing, and maintenance of ammonia refrigeration systems. Very straightforward. I'm going to show you 4 parts here. It has a general purpose, scope, and applicability. And then there's program administration, and it goes through the inspection, testing, and maintenance program requirements, frequencies of when these inspection, testing, and maintenance items should be done, the record keeping for them, and then, of course, general requirements for ITM tasks. ITM is abbreviation, inspection, testing, and maintenance. And then, of course, the equipment. You'll see I have some items highlighted there. I'll show a little bit more on those. Then there's a part 3 that in the informative appendix that has explanatory material.
Tony, may I ask you please to concentrate in having your voice constant, because it's sometimes lower, it's sometimes it's higher.
Is it going up and down?
Get closer to the mic.
Okay, I'll talk a little louder.
Oh, good. Yeah, that's much better. Thank you very much.
Okay, and the part 3, the appendices has explanatory material. And also I want to show you, we also have ammonia refrigeration safety inspection checklists that are included. So let me give you some examples of these. Here is an example of a pressure vessel inspection, testing, and maintenance sheet. You're seeing just the top part that shows the inspections. There is inspection, testing, and maintenance items on the sheet, but it's 2 or 3 pages. But you'll see inspections A through L, I think, is shown on the side as an inspection, and then the frequencies, whether the pressure vessel is insulated or non-insulated on the right. Here's another example, piping. Shows some inspection items on the right side, and then also the frequencies for insulated, insulated or non-insulated, whether it's carbon steel or stainless steel, down the right side. And we have a chapter 12 that has safety systems for inspection, testing, and maintenance tasks. And these items are including emergency ventilation systems, emergency shutdown switches, ammonia detection and alarms systems, computer control safety systems, and emergency eye wash and showers, which I've showed some pictures previously. And here's another example, overpressure protection devices. It shows the inspections on the left, PRV, pressure relief valve, and then of course on the right, it shows PRV, whether it's going to atmosphere or it's a hydrostatic or internal relief back into the system. And I want to show, here's a purger inspection, testing, and maintenance sheet. The reason I'm showing this one is because this is a smaller one, so you can see each of these sheets that I previously showed do have inspection, testing, and maintenance items on them, but the others were so long. So this one shows inspection here with 4 items, testing with 2 items, and maintenance with 5 items. So you can see that each sheet would have all these items listed. Depending on the piece of equipment, some have more, some have less. And then of course the right shows the frequency and it has a definition of what it is, and then how frequent it should be, where applicable, daily, monthly, annually, semi-annually, and such. The other thing I want to share with IR 6 is the ammonia refrigeration system safety checklist. Here's a cover page of a pressure vessel checklist that you would take and fill this information out for that pressure vessel. And then in the future, more than likely, that would be filled out and you would not need to change it unless something did change. But once it's filled out, it's a done deal in most cases. Then the next page has the other inspection items that you would list out. And you would have you'd go to check each one, conforms, yes or no, or not applicable, its status, recommendations, and such. So those are the ammonia refrigeration system safety checklist for the different types of equipment that can be utilized as well. Now, the REGA gap in ARM, meaning ammonia refrigeration management, in regards to control or mitigation, this for the risk associated with ammonia use, but we want to ensure refrigeration systems efficiency as well as also it being safe. So ReggaGap helps not only with the safety to control or mitigate, but it also ensures its efficiencies. And the ARM manual, which is pictured in front of you, is an important part of ReggaGap and consists of a series of practices that helps us maintain safe and efficient systems. And the purpose of the ARM program is it's a voluntary program designed to help end users supervise their refrigeration systems in a safe and responsible manner. And it's, of course, for installations that use ammonia as a refrigerant for this item here. What is included in the ARM elements, as shown here, a list of items: management system, participation and supervision, documentation, risk analysis, and developing procedures, hazard review, which is highlighted. I'll share a little bit more on that. Training and emergency preparedness, emergency readiness as a response plan, incident investigations, audits, and manage changes. So I'm going to go back and cover a couple of these, but definitely the hazard review. So in regards to participation, which is central, management's commitment is key to the steps for the participation of those involved, for establishing responsibilities, employee participation and access to information, collect necessary documentation, and establish an agenda of activities such as audits, and establish actions to take for changes of the system, accidents, maintenance, and such that could be used to help train the employees. And now the management system, also this ARM provides guidance so you can adopt and adapt.
ولا تقدر تساعد المشترك. طبعا بعتذر ما كان في الصوت، الآن وصل الصوت.
Hello? Yep. And documents that are based on ReggaGap will help.
طبعا الآن أتمنى بأن هذه الشريحة ستساعدكم أيضا.
Do you see the documents that are shared for the ReggaGap document? There's a few highlighted here. I'm going to go through a couple of these very quickly. Here's an ammonia inventory worksheet for pressure vessels. As you can see, there's 4 pressure vessels listed out due to the volume, temp, and refrigerant density. Then you come up with a total. And then this can be transferred to this sheet. So now you have your pressure vessel inventory on the top. You have piping, air units, special purpose equipment, evaporator condensers, and then you come up with a total for your ammonia inventory for that system. This is a short, small example of your ammonia inventory. Also, there's equipment lists for, you could list out compressors, evaporator condensers, vessels, and carry through the information so you have your table filled out. And then there's technical operating specifications for safety systems. So you would have your piece of equipment, and then you would clearly define what are the safety systems for each of those equipment that you can include, such as it shows here down the line for compressors, condensers, pressure vessels, or even a low pressure vessel as an example. And also system diagrams. Here's a diffuser detail or even a P&ID of a compressor, and shows how it connects to your piping headers. Now, there's certain things that are in the materials of construction are permissible and not permissible. And obviously cast iron, malleable iron, nodular iron, steel, cast steel, and alloy steel are fine as long as they comply with, we stated as ASME B31.5 or ASME Boiler and Pressure Vessel Code, Section 8, Division 1. What's not permissible is zinc, copper, and copper alloys, and also ASTM A53 type F pipe, cast iron or wrought iron are not usable for the pressure containing portion of the not closed circuit of the refrigeration system. And even malleable cast iron fittings are not allowed per ASME B31.5 for your information as well. Now, ReggaGap itself, here's an example where if you have a 150 ppm ammonia detector, and if it's activated, it would send a signal to the emergency ventilation system, activate it, and you'd have 30 air changes per hour, which would reduce the concentration below any ignition point. And you could even install another detector that's even at a high level, or even at 40,000 ppm, or the highest level that detector can handle, and then it would de-energize electrical equipment, and then it would make so the machine room is not hazardous because the electrical is taken offline and there's no risk of an ignition point. And also a little bit more quickly on the risk analysis and developing procedures, your documents that are used for ReggaGap are used to help with your risk analysis procedures. And then from there, you come up with a hazard review. So you end up with a complete, organized, systematic process of identifying, evaluating, and controlling potential hazards associated with the process. And obviously, there's steps with that. And the what if checklist is a method that is commonly used in our refrigeration industry that includes those items that you would want to what if questions on for process risk, previous hazards, system and equipment siting, human factors, and then the evaluation of risk based on existing engineering and administrative controls can provide you with a rating. Here's a little example where you have your equipment such as compressor, you ask a what if question, you get a scenario, and then you get a consequence. And such a little bit more on what the tail end of that table means is the EA obviously engineer administrative controls, and then the C stands for consequence and severity, F is frequency, and those two combined will give you a risk ranking. And then you can respond to how you're going to correct or modify or whatever it needs to correct the situation of a deficiency or something that was found that should be corrected in a timely manner. And then, of course, that shows the table where you have your frequencies and your consequence severities, and you come up with an A, B, C, or D rating. Here's some examples. I just pull these off at the top of the atmospheric reliefs, where is rain and snow or whatever is the weather are the items being protected so the weather can't get within the system. Here you show caps, bull's horn device, a bird's nest type. Those type of items will keep the weather from getting in. But then there's an example here when you're looking at this relief here, either shows it's shooting or would discharge horizontally or downward, which is not what you want. You want it to go upward. Here's an example of a hazard review item where you could find where there's an exhaust fan here on the roof with a mushroom type hood on it, so it's not going to discharge directly upward. It's going to come up and onto the roof, and if someone were working in that location near that condenser, if there was a ammonia release, it would just exhaust into their area and they would be exposed to it. So that would be a finding that you'd want to correct. Now, developing procedures for operation with the documents is important. And I'll list out some of the items here. You gathered the system documentation for REGAP, you completed hazard reviews, and you get all through all this information. And so all these procedures that you develop for operating procedures, of course, they need to be written in a written way that the operators can understand. They include all the equipment for the operations, describe operating limits, health risks and ways to reduce risk, et cetera. So now this other item beyond just operating procedures, when you develop them, is their safe work practices. And I'll list a few here: lockout, tagout, confined spaces, entry, line opening, oil draining from the system, working at height, which is fall protection, adding oil to the system, contractor safety, control access, electrical safety, and ground disturbance are few of the other safe work practices that you want to include with your operating procedures and train your employees. So obviously you have your documents based on REGAP. You can develop your risk analysis procedures, and then you have training and emergency readiness that can come from this. And in regards to that, your operating and maintenance procedures will serve as training material and materials used for emergency preparedness. So it's important to have your operations and maintenance procedures developed. And all the persons should be trained on the overview of these safety risks, ammonia properties, and such, and procedures for operating and testing and maintaining the system as well. I'm going through it very quickly. I just want to show you some of the highlights. Emergency readiness as you prepare, which you plan based on risk assessments, hazard review, you mitigate. So you have plans to reduce the risk identified, and then you respond. So your response will be determining actions to take during emergencies, and you recover actions to take for returning to normal operations. And one of the key items here is this is just a continuous process that you get familiar with and you practice. It becomes your culture. You prepare, mitigate, respond, and recover. And one of the key items here I want to show this is what's located beyond the fence. So if you were unfortunately have a release, you want to keep it on your property if at all possible, but you want to know and be prepared that what can you do to try to keep it from going off your premise. And anything could happen. It could be even unusual, not even related, but that's where response is important to be planned for. And one other item on the ARM is that the emergency response plan has tracking sheets just like this that can be used and modified as needed so it can adapt to your system. and a little bit more on this. So we have incident investigations, audits, or ongoing risk analysis and managing of changes can be done with all your information totally based from your documents to your risk analysis procedures and your training. So I won't read through each one of these, but you have incident investigations, audits, and managing change. All these come out of your documentation and you can use for your training of your employees and emergency responders and such to help you, and also for your decision making. If there was an incident, or if you find something in an audit that you can correct it, in order to manage change to make sure the system sustains its integrity. So here's one last sample here. If you're out doing an audit, you can go look for corrosion exterior on the piping, or you can look for excessive ice buildup as some examples of what items you simply can look for, and you can train your operators to be on the continuous lookout for this. And then also look at your piping. Do the employees understand what's in these pipes? Would color coding help the pipes? The pipe labeling could be put on so you know what's in those pipes, low pressure, high pressure, and which direction it's flowing, and then train on that. So here's an example. The picture is we understand, of course, these are condensers, but somebody may not, and you say, well, maybe it would be good to have the labels definitely on there. The color coding could help, and then train on it. So in the conclusions, the IIAR manual is an important part of the REGIGAP. It provides template procedures already developed that could be used as tools, and it consists of a series of practices that help us maintain safe and efficient ammonia refrigeration systems. And then we also have a IIAR Academy of Natural Refrigerants that train on each of these courses for the IIAR2 Safe Design, IIAR6 Inspection, Testing, and Maintenance, and the ARM Ammonia Refrigeration Management Program. So I went through these very quickly, but I wanted to share some of the highlights of the IIAR2, IIAR6, and then the ARM.